I started in this industry back in 1969 with a job at Capital Controls Company up in Colmar, Pennsylvania, and they were manufacturers of gas chlorination equipment. And the man who started that company, Jim Haskett, he had invented the direct cylinder mounted gas chlorinator back in 1960. Kind of changed the industry completely. I started working in the advertising and marketing department. I was a technical writer, redoing all of their manuals and so forth, and eventually took over the advertising and then the marketing. But I was also sort of an assistant to Jim, and he became my mentor and my friend. Taught me a lot about gas chlorination, pretty much everything there was to know. Took over all the marketing programs until he left in 1973. Big company bought Capital Controls. I moved down to Florida to join Jim in end of 1975, and started another company down here. And we developed another gas chlorinator, improved some of the materials and so forth. He passed away in 1989, and I kind of retired in 1991. Thought I was going to go into consulting, did some consulting work, but people kept calling me, including a very good friend of mine in France who came over here unannounced, knocked on my doorstep one day, said, "We have to go back in the gas chlorinator industry." And he convinced me to do it. He was a good friend of mine and a distributor of ours. So I sat down with a drawing board and started redrawing gas chlorinator, and quickly realized I didn't want to do that. So I took up a CAD program. This was fairly new at that time. There weren't too many of those things around, and it was wonderful. If Jim had seen that, he would have loved it. And I designed the superior gas chlorinator, improved a lot of the materials, made the design simpler, and the rest is history. We took off, created a company that would not only had a better piece of equipment, but I also wanted a company that was built around the way I wanted people and companies to treat me when I would call them. So the customer service aspect was a major, major point for me. And I went around and talked to a lot of people in the industry and said, what do you want to see in a gas chlorinator? What do you want to see in a company? How do you want the pricing structure? And we changed the whole paradigm for selling and for marketing and producing gas chlorinators. Oh, many, many, many changes. The interesting thing, though, in this industry, changes are slow to come. Then there'll be a major change, and then not much going on for a long time. When I first entered the industry, the last major change was in 1960 when Jim Haskett developed the direct cylinder mounted gas chlorinator. It was a major, major change in the way people handle gas chlorine. Made it much more safe. You didn't have the pressurized piping and everything involved in that. The vacuum regulator mounted directly onto the cylinder valve. It eliminated all those potential pressure leaks. Anything happened, you lost your vacuum, everything shut down. And for many years, that was the standard. We made it so that you could mount it also on a ton container of chlorine, 2,000 pounds instead of a 150-pound cylinder. And along around 1970, we came out with the first automatic chlorine residual analyzer. That was the next major change that happened in the industry. There had been ways to automatically measure chlorine in water up to that point, but they were complicated, big, expensive pieces of machinery, and they weren't very accurate and prone to a lot of problems. This was a big change in the whole industry. So from 1969 on, the biggest change we had in the industry was in the instrumentation side, not really in the mechanical equipment, until 1992, when we came up with superior gas chlorinator. Big change in materials design. My engineer that had been with me at Chlorinators Incorporated, which was the second company I was with, he and I did a lot of work in materials testing. You can look at chemical resistance charts all you want, but they don't really tell you a lot when you're dealing in the real world with chlorine. Chlorine gas, liquid chlorine, wet chlorine gas, dry chlorine gas, all kinds of problems and things. You have to try it. So we did a lot of this stuff. We call our torture chamber. We put things in there for 6 months in chlorine gas and wet chlorine gas. And we came up with a lot of new things that would work with chlorine. And these are the things I incorporated. And I had a lot of experience in the plastics materials industry. When I was with Capital Controls, they loaned my body to their parent company, plastics division, to help them with some marketing programs. I learned a lot about plastics. There was a company out of Indianapolis called Fiberfill who had started using fiberglass reinforced plastics. They were kind of pioneers in that industry. They taught me about a lot of that stuff. And when I started this company, Chemical Injection Technologies, I said, you know, I really want to take advantage of that stuff. And this is the first chlorinator in the world, and still the only chlorinator in the world that still use fiberglass reinforced plastics. Now, why is that important? Strength, ability to hold its tolerances, because plastics move. They absorb moisture, they move with heat and cold, and it can become a problem. They can crack and have a problem. We have never seen a crack in one of our molded pieces ever. So it's so much stronger. I remember when I went to a show up in North Carolina, first trade show, and it was the North Carolina Rural Water Association. And I brought one of my vacuum regulators, and I had a board and had some nails in it. And when people would ask me about this, I'd say, well, it's stronger than anything else on the market. It never cracks, and they wouldn't believe me. So I took it and I hammered nails into the board with it, and they were just like, no, I can't believe you can do that stuff. This immediately got a lot of attention from these people. And I picked up 3 distributors at that show. So there's a lot of new things. Also, materials, metal material. Metals are very, very, very susceptible to corrosion with chlorine. Chlorine is a reactive material. It reacts with almost anything. That's why it's used so much in the chemical and pharmaceutical industries. It's as a binder because it has the ability to bring chemicals together, that would normally not be compatible. So the problem we had was you have to bolt together the regulators and parts with bolts, with metal bolts. Well, people that used stainless steel, that doesn't work. Chlorine goes right after that. Monel, which is better than stainless steel, but ultimately it will start to corrode, form a green, slimy substance on it, especially in between the regulator bodies. And eventually the screws got smaller and smaller and smaller diameter, and they break. We had tested a lot of titanium materials when Chris and I were doing some of the materials testing. And we found that if there was any moisture at all, chlorine didn't affect titanium at all. It's called passivation. It's the oxygen in the water or the air. We also found out if you use dry chlorine, it didn't work very well at all. But on the exterior part of the chlorinators, it was fantastic. Nobody even thought of using titanium with chlorination equipment before. I started using the titanium nuts and bolts, and we found that nothing affected it. We guaranteed it for the life of the bolts. Nothing has ever been done like that. Got a lot of criticism for it, but ultimately, it's been accepted very well. We don't sell nuts and bolts. In fact, it's one of the things that our distributors complain about. They can't sell enough parts because the things don't break. Well, it kind of depends a little bit on governmental and regulations. There's been a lot of, I don't know what you want to call it, not yellow journalism, but it's scare tactics that manufacturers of other competing types of disinfectant materials have been putting out about the relative safety of chlorine versus other, what we call inherently safer technologies. And it turns out they're neither. They're not safer, and they're not inherently better in any way, shape, or form. Chlorine has gas chlorine especially has a very enviable safety record. Part of it is because of the fact that it comes in this pressurized cylinder, and people give it a lot of respect. Sometimes liquid bleach or sodium hypochlorite doesn't tend to get the kind of respect. It's a liquid, it's in a carboy, and people use it around the house, and they think it's the same thing. And there are a lot of problems with spilling and splashing and skin burns and all kinds of things. And in the last 20 years, there hasn't been a death due to 150-pound chlorine gas cylinders anywhere. Far fewer accidents. The people that keep track of industrial accidents know that the amount of problems, not deaths, but sicknesses and other things due to the other types of disinfection are far greater than gas chlorine. So gas chlorination in itself is here to stay. It's a question of how much the government wants to clamp down or move things around. We're seeing a big change that happened, maybe 8 or 9 years ago, especially after the Iraqi war, where the insurgents used chlorine a few times to try and scare the populace, but they quit it very quickly because nobody died from it. In fact, in Fallujah, detonated 2,000 pounds of high explosive on a truck full of chlorine cylinders, wiped out one square block completely. Nobody died of chlorine gas inhalation, but they died of shrapnel. So it's that sort of thing. But it got picked up by the media, and there was a lot of push from certain quarters to stop using gas chlorination due to homeland security at wastewater and water treatment plants. Oh my God, terrorists could use this. It's a totally specious argument. It never happened. It couldn't be happened. In fact, the only time it was even a problem was at a treatment plant in California where 2 cylinders were stolen, but it turned out it wasn't for that reason. It's because they thought it was ammonia and they wanted to use it in methamphetamine production. So yeah, it's heading in that direction. Then suddenly, in the last few years, many of the people that changed over from gas chlorination to liquid bleach, to UV, to other forms, are moving back to gas chlorination because they find it's easy, it's cheaper than any of the other forms of disinfection. It has to be used even with some of the other forms of disinfection because they can't maintain a residual amount of chlorine in the distribution system. After the water leaves the treatment plant, now what? You have cross connections, algae and slime formations in the pipes. It can get reinfected. Breaks can suck in bacteria. So you have to have something in the water down the pipe so that any bacteria that gets in after the treatment plant will simply be taken care of. And we try to maintain about a half a part per million of chlorine at the farthest water tap. So it's still used even when you're using ultraviolet or ozone or other technologies because they can't maintain this residual down in the system. We think gas chlorination is here to stay. Our company is hedging our bets a little bit because we've developed some new technology in feeding liquids. Instead of the old chemical feed pumps, which are a pump, usually a diaphragm pump that moves the chlorine through the pump head, pulls it back, pushes it in, has check valves. Many of you have probably seen these types of things. They're problematic. They stick. Sodium hypochlorite has a tendency to off-gas, air bind the pumps. The strokes aren't the same, and the mixing is very poor. You get it in slugs, where chlorine gas normally is just very easy, constant diffusion of the chlorine. Well, our liquid technology uses the same type of equipment used for the gas feed. We do it with a vacuum. We form a vacuum with Venturi, and we pull the liquid, if it's sodium hypochlorite or sodium bisulfate or any of the other chemicals we can handle, it pulls it through in a vacuum, and it disperses it into the liquid, very, very fine bubbles. You get very good mixing, and it's constant, not periodic slugs of chemicals. And this is starting to catch on. It doesn't have any motors, no moving parts, no mechanical stuff, and it's much more reliable. So that's part of the way the future is going. And we've come up with a few other interesting technologies, and we're still working on some technologies in terms of instrumentation and even bigger feed rates. We can now go all the way up to the biggest wastewater treatment plants in the world. We can handle those. So I'm particularly proud of the Chlor Clearer. This is an interesting little piece of equipment. When you use the 2,000-pound chlorine containers, these drums that lie on their side, and you withdraw the chlorine from the end instead of from the top, but there are always 2 valves because you can withdraw liquid chlorine, liquid elemental chlorine that's in the cylinder. Let me also point out that the chlorine in those cylinders or in those ton containers is in a liquefied form, kind of like liquid propane that you would use for your barbecue grill or one of those things. And then as you release the pressure, it boils off inside and it vaporizes, and that's what you're pulling off, the vapor. Well, with the ton containers, you have to roll these things in the position. So to get the gas out of it, there are tubes behind the valves. They kind of go up like this to the outside of the container. And when you align these valves, you have one in the bottom that can pull liquid out, if you're using a liquid vaporizer for very high capacity chlorinators, and the one that goes to the top withdraws gas. But the first time you open that valve, you're going to get liquid because that's what's in that tube. And that contains a lot of sludge and other things that form inside the ton containers over the years, and you don't want liquid in your chlorine feed equipment. I might add that the superior equipment will handle the liquid. PVC equipment made with PVC will not. Liquid chlorine will destroy PVC. It looks like a somebody took a blowtorch to the inside of it. The ABS that we use will handle the liquid chlorine. It might bubble a little bit on the surface from the cold. It's like an air conditioner, vaporizes and gets cold very quickly. So the problem here has been, you've got to do something with this liquid and the crud that comes through there. And we and other manufacturers have made adapters that go on the ton containers that divert this liquid and put a little heater around it to vaporize it. And that works to some degree. But that sludge that's in there is left behind. And eventually that builds up and plugs it up. Sometimes if the ejector that produces the vacuum, the venturi that produces the vacuum, is running along, the liquid can come through so fast that it doesn't even get a chance to vaporize, and sometimes it gets sucked up into the equipment and causes all kinds of problems. Well, I guess about 15 years ago I had this idea to somehow eliminate the liquid in the ton containers. We blow it out with nitrogen. I presented this idea to some people in the industry, especially one organization that kind of writes all the, not the rules, but the standards, and they didn't think it was a good idea because, oh, you can't put gas in the ton container. Well, I kind of dropped it until a distributor and friend of mine out in California was having a lot of problems with many of the ton containers he uses out in the agricultural installations he has, where they have to replace these ton containers on a regular basis. And they were having difficulty with the liquid getting in, getting trapped between the inlet valve of the chlorinator and somebody turning off the valve of the ton container. Creates a lot of pressure in a system that you shouldn't have, especially out in the heat in California. So he was looking for something that would allow me to put more liquid in there so it could vaporize better. And we did one of those. It was very heavy. I said, you know, I had this idea a long time ago to make this thing with a nitrogen, we could blow it out. Let me try and work on it. And we did. We worked on this, and we came up with our ChlorClear, our liquid ton container eductor evacuating system. It's amazing. Everybody who sees this says, why didn't somebody think of this a long time ago? I said, I did, but nobody really thought it was a great idea back then. And everybody that sees it thinks this is the greatest thing since they started using ton containers. It's a big change. We're also working with our chlorine residual analyzing equipment, water quality equipment. We're trying to improve all that stuff for various parameters, not just chlorination, for total dissolved oxygen, for hardness, all kinds of things that we think we can automate in combination with this, and our automated systems. We can automate the control of the chlorine by reading the residual or reading the flow of the water and varying the chlorine feed rate based on the parameter we need to adjust to.